You're asked to simplify each of the following expressions. So when I look at these, honestly, the division isn't super scary. The powers of powers is not super scary as long as you know that what it means to have a negative exponent. The thing honestly that worries me the most is this first one, because I have this addition thing and then this fraction here that it's multiplying together. And if you're not careful, right, what some people might do is you might like take this and distribute it to both of these, which is for sure one way to do it. The only issue with that is then you get this addition problem that becomes really hairy and not fun to deal with, because you're going to have all of this, plus all of this other stuff with these denominators that are not fun to deal with. So I'm actually going to do two things before I do the multiplication. I'm going to combine these, so I'm going to somehow simplify this into a single fraction, and then I'm going to factor this denominator here. And you'll see why that's helpful once you see what's going on here. So if I'm working with 1 plus x over y, I need to have a common denominator, so I'm multiplying by a giant 1 on the left here. And I get y over y plus x over y, which is the same thing as x plus y over y. So not to confuse you, this first step was just changing that first term into a single fraction. So x plus y over y. Now I have this times my second piece, which I'm going to also change the way that it looks, because I see the denominator here is a difference of squares. So what that means is I can break it up into x plus y times x minus y. Now, hopefully you're seeing why it's helpful, because now I've done all the hard parts by breaking this up as much as possible, because what you can see here is that we're really doing x plus y and x plus y, which cancel out. And then we have this y cancels out with this y here. And the reason that we can do that, and this is where most people get confused, is because we are multiplying these things. I'm looking at this as one piece of the left side and one piece of the right side. That is why I can cancel them out. If I was adding or subtracting between these, then I could not cancel. But I'm able to, and therefore what's left over when I'm done is just 4y on the top and x minus y on the bottom. And so that's what we get for A. Now, division here, I'm going to erase this stuff so you can get some more space here. So the division, first thing to remember is that when we're dealing with division of fractions, it's the same thing as multiplying by the reciprocal. So I'm going to rewrite this here. And this problem, honestly, is just a lot of practice with factoring. So if we get to here, then now that we're multiplying, really we're just multiplying across, but I want to factor these things that are able to be factored. And so this first part here, if you were to use the diamond in the box, you'd get x minus 4 times x minus 2. The bottom here is a difference of squares, so x plus 4, x minus 4. We have x plus 4 here from the top, and then if we were to diamond and box the bottom right there, that would be x minus 2 and x minus 2. And now, again, because we are multiplying here, I can cancel these things out that are the same. So I have an x plus 4 on the top and bottom, an x minus 4, and x minus 2. The only thing left on the top is 1, and the only thing left on the bottom is x minus 2. So for C here, last one, we just need to know our power of a power rule, meaning we're really just going to distribute that power to everything, like multiply it. And then we got to know our negative exponent rules. So once I distribute it to all of those things there, does that actually work? Hold on, let me double check. So I got x squared plus x over x to the power of negative 1 plus x to the power of negative 3. I may have misspoken on that. I actually think that when we're dealing with this one, because there's the addition, remember when we have something like x plus 3, we can't distribute that, or if it was squared or something. Yeah, so made a little mistake there. So instead of distributing that -1, instead I am going to take the reciprocal of the whole thing. Because it's to the power of -1, I'm going to say x plus x to the power of -3, and x to the power of -2 plus x to the power of -1. So that first one, instead of distributing, because I have this plus sign, I cannot distribute that exponent. And so instead what I'm going to do, because it's a negative exponent, that means I just take the reciprocal of it. Now I am going to get rid of these negative exponents by using my rule about negative exponents, like so. And now that I have this, I need to get rid of the fraction within a fraction. And to do that, I need to figure out what can I multiply by the top and the bottom that will get rid of all of the little denominators. In this case, it is going to be x to the power of 3. So now I distribute, because I'm multiplying and not using an exponent. I get x to the power of 4 plus 1. And then I distribute on the bottom here, and I get x plus x squared. And that is my final answer. If you want to make it look nice and pretty, we got looks like that if they're both in standard form.